So if you're not completely covered in blood by the end of it, are you even doing real mathematics? Happy Pi Day, everyone! The very day on which we celebrate 3/14, March 14th, 3.14, a wonderful day to celebrate mathematics and, of course, to eat pie. And so it's time for our annual, or at least annual-ish video in which we combine horror and mathematics. If you don't happen to like math, stick around anyway, because these are always fun things to do. But if you do happen to enjoy math, this is going to be a fun one as we use a kind of blood splatter analysis to bring a horror theme to our attempt to empirically estimate pi. In case you're new here, let me just first of all say welcome to my channel. This is a horror channel rather than a math channel, so it's only once or twice a year that I'm able to combine these two passions of mine in this way, but I'd encourage you to subscribe and ring that notification bell so that you can stick around for all kinds of spooky horror genre fun. And of course, if you like what I'm doing, be sure to click that like button to feed the algorithm. And of course, you have my thanks in advance. So, how come we're combining horror with mathematics? Well, honestly, it's just one of those things I like to do. In fact, last year I published this anthology of mathematically inspired horror stories called Arithmophobia, and I'll link you to all the details down below, so if you want to check it out, you can, and there'll be purchase links and all that sort of thing. You needn't even know any math to like this book. These are just really good horror stories that I curated from some great authors that happen to have some kind of mathematical theme or flavor or inspiration or whatever you would say. So if you don't know any math, they're great horror stories. But if you do know some math, there's little Easter eggs that maybe mathematicians would understand. But like I said, you don't need to know or like any math to enjoy that anthology. But as you might guess, based on my publication of that book, I of course have passions for both genres, horror and mathematics. And since this is Pi Day, one of the things a lot of math people do to celebrate this particular, most mathematical of all the holidays is to find new and unusual ways to calculate or estimate everyone's favorite circle constant, pi, of course. Because I'm a horror nerd, I try to find horror-related ways to do it, which brings us to our blood splatter experiment. The idea is to use blood splatter to estimate the respective areas of a square and a circle, and then to use the relationship between those shapes in order to estimate pi based on a simple formula. Now, blood splatter analysis is of course a normal part of forensic science. Technicians or investigators can look at streaks or droplets of blood and figure out a lot about that blood's source. Based on how they spread out, they can figure the direction of origin, their angle of approach to the final wall or sofa or whatever they happen to have hit. They can find the approximate speed at which each drop traveled until it hit the wall, and all of that can help figure out what type of injury or weapon produced the blood splatter. So for example, if a knife were slashing, that would produce elongated splatters, whereas something like a blunt instrument might produce a more circular drop-like splatter, that kind of a thing. Perhaps someday I'll make a full video exploring in a bit more detail how that all works out and how blood splatter analysis is done. Let me know down in the comments if that's something you'd be interested in. But for today, we don't need all of that physics or trigonometry or any of that sort of research that goes into traditional blood splatter analysis. We just need a simple formula so that we can estimate pi using a really pared back and simple, almost simplistic form of blood splatter analysis. And it's all based on the relationship between a simple circle and a simple square. So the first thing we're going to need is a circle inscribed within a square so that the circle's diameter is equal to the length of the square's sides, as you can see in the image that I'm going to put up on the screen for your convenience. What we'll do is we'll make a real-world version of that figure, then we'll splatter it with blood splatter, and then we can count up the blood splatters. We can count the droplets to estimate the area of each shape. And specifically, we're not going to actually calculate the exact area. We just want to know the ratio between the circle and the square. So the idea is going to be that even though we may not know the exact area, the amount covered inside and outside the circle should be proportional to the area. And then we'll use that information to follow a simple formula to estimate pi. And I'll give you that formula, and this is how it's going to go. I'm going to put an equation up on the screen, and in that equation, you can see that I've set up a ratio of the area of the circle divided by the area of the square. And again, we don't need to calculate or measure the areas, we just need to figure out that ratio or the proportion of blood splatters in each segment of our figure. We do know that the area of a circle is pi r squared, and I've shown it here in the equation as pi times half the diameter squared, because we're going to deal with diameter instead of radius, but diameter is just twice the radius, so that works out. And we also know that the area of a square is just the side length squared, and here I've shown that as equal to the diameter because we're constructing our circle and our square so that the diameter of the circle is equal to the side of the square. So the circle perfectly fits in the square, and that all works out nicely. And then, also as shown in the equation I'm putting on the screen, if we just simplify that expression down, we find that our ratio of the circle to the square comes out to be equal to pi over 4, as shown. What that means is that if we just solve that final simple little equation for pi, as I'm putting on the screen now, we can see that pi should be equal to 4 times the ratio of the circle's area to the square's area. And that's it. I used an approximately equal to sign because I'm going to be approximating the area when I compute that ratio, but if we knew the exact values, that would actually be an equal sign. But that's it. That's all the math we need to do for today. And once we figure out those values, we just plug them into my trusty old calculator, this lifelong friend that I've had for decades at this point, and we'll have our estimate of pi. As I said, to make this horror related, the way I'm going to estimate it, this is usually done with like throwing darts at a dartboard. But my idea was to make it horror related. I'm going to use this blood splatter analysis, and I'm going to splatter stage blood onto the circle and square. Then I just count up all the blood splatters inside the circle. Then I count up all the blood splatters outside the circle. And so if I add those together, then I'll get the total number in the square, and then I'll have the number in the circle, and I can compute that ratio. Then I just plug that ratio into my calculator, multiply by 4, and hopefully, fingers crossed, it should be pretty close to the true value of pi, which we know is 3.14. Anyway, that's the plan, so let's head outside and get ready to make a bloody mess of things. The next time you see me, I'll be wearing my lab coat and ready to get bloody. So the idea here, I have a piece of poster board with a circle inscribed within the perfectly square, I cut it perfectly to square poster board. The idea is that the diameter of the circle is equal to a side of the square, and so we can use the calculation that I showed you and calculate the ratio of the area of the circle to the area of the square, and that should be related to pi. Now the idea with this experiment is we'll use blood splatter on this poster board, and we'll count the number of dots in the circle and the number of dots not in the circle, and we'll be able to compute that ratio. We'll approximate the area using the number of blood splatter marks, and then we can use that in our estimation of pi. The trouble is, there's a couple problems with this. One thing is, in order for it to work properly, in order for it to be a good estimate, forgive the sound of the dogs barking because I'm recording outside, in order for this to be a good estimate, the splatters need to be random, and since I'm doing this myself, humans are terrible at doing things random. I'm going to do my best and be as random as possible. The second problem is, in order to get a good estimate, we would want as many dots as possible. We would basically want to fill this thing with dots, but the more we fill it with dots, the harder it is to count, and the more they run together, and we have to make judgment calls and things. The fewer we have, the less convergent, the less close to convergence we should be in our probabilities, but yet the easier to count. So we need to find sort of a middle ground there as well. I'm going to do my best. This is a very rough estimate. Hopefully it comes out somewhere near the true value of pi by the end. We'll have to wait and see. In order to do this calculation, of course, I have my poster board with my circle. I also have my trusty lab notebook right there behind me, and I have a dollar store spray bottle filled with my own special blend of stage blood. And I've tested, and it doesn't pump through great, but good enough. I should be able to get enough splatter to make this thing work. So I'm going to set up over there on a tree stump, and let's get to it. This spot right here is where all the action is going to happen. I'm going to step back over there, and I'm going to start splattering. There it is. Time to let that dry a little bit, count them up, and next time you see me, we'll have the results. Well, that's done. You've seen me set up the blood splatter analysis. I've now come back inside. I have counted up all of the blood splatters, which I have to say was not the easiest job in the world. As it turns out, there were damn near 5,000 of them, and I was counting by hand, circling each one to make sure I didn't double count any. I'll show you what it looks like, and you can see that it was quite the process indeed. Pardon me for holding this in front of you, Dr. McCoy, but this is our blood splatter, and as you can see, I have circled each one of them. Some of them sort of ran together, particularly down in this corner, so I had to kind of fudge it and do my best to estimate the actual number of splatters, but I spent some good time and worked as closely and looked as closely as I can, and I think I came up with a pretty good estimate. Never let it be said that I don't suffer to bring you these fun videos. Anyway, I have got the final numbers in my notebook here. Inside the circle were 3,778 blood splatters, and outside the circle were 995, which brings us to a grand total of 4,773 little blood splots. And now we're not actually interested in the number outside, we're interested in the total number, in the whole square, and then we're interested in the number within the circle. So if I divide 3,778 by 4,773, then multiply that by 4, I should get something pretty close to pi. We know, of course, the true value of pi is about 3.14. It's actually 3.14159 and change. So let's punch it all in. And drum roll, please. Yes, our answer, our estimate of pi comes out to 3.166 and some change. Honestly, that is pretty good. 3.14 is the true value. I got 3.16. So ever so slightly overestimated pi. But if I do a quick check to find the percent error, let's do that now. Now I find that I'm actually only off by 0.78%. So less than 1% difference from the true value. And that honestly is really close, especially given all the caveats and inexactitudes in my methodology. In fact, I think in all of these Pi Day videos that I've done over the last several years, I think that's the closest to the true value of pi that I've ever come. There are some people with more resources than I have that have done a little bit better, but that's really close. So I'm a happy little nerd indeed. So that brings us to the end of our video for today. Alas, Do be sure to like, share, subscribe, and all that. All that stuff really does help me out. If you liked this video even a little bit, I'm sure you'll love my arithmophobia anthology, so you might want to do me a favor and check that out as well. Most importantly, though, it's Pi Day. And though Pi Day is named for the mathematical constant, it's also a great excuse to go eat some pie. So do that. And as always, take care and stay scared.